Our architecture has come a very long way. With centralized monitoring and logging set up, we'll be very aware when we need to change something in our infrastructure. But even though we may be aware for the need for changes, so like scaling the number of servers we have, we'd still have to do that manually. Now, considering how easy it is to set up servers and add them to AWS, it's not the worst task to have. But the problem with doing it manually is, well, it's really two main things. The first is timing. So you may be aware of the need for scaling after you wake up, get to the office, and users have been getting denial of service errors for hours. Well, there we go. That kind of sums up the problem. If you're scaling manually, well, then you better be ready to do it when you need it. And unless you're staying up 24/7 watching things, that's going to be near impossible. I suppose you could also have your phone set up to receive CloudWatch alarms whenever you need it, but that's kind of a recipe for insanity. But timing is a major problem when it comes to scaling. But the time you figure out you need to scale, it may be too late. And the reverse is true. You may not need servers that you've created to handle scale anymore. And if that's the case, well, then you're paying for them and they're just sitting there unused. The second thing is magnitude of change. So that's a fancy phrase that really just means this. Okay, we need to scale up to meet traffic. Great. How much do we scale by? Well, this is a whole art and science that comes with a ton of difficulties, as you can imagine. Now, this is one of the main problems that comes with traditional data centers and managing your own servers. How much do you scale out or in by? And how do you make it so that you can match your traffic with just enough power? That way you're not wasting money on resources you don't need. Well, this graph kind of sums up the problem. We want the power of all of our servers, so the provisioned capacity, right? We provision servers to meet our traffic, and that's the capacity, right? We want the power of all of our servers, so EC2 instances, to be able to support the traffic levels coming in. But at least in manual scaling and physical infrastructure, well, this becomes an entire game in focus. And quite frankly, until you know your business, the application and its metrics like the back of your hand, well, I guess if you're clairvoyant as well, that would help. You're probably not going to get this right very often. There's going to be a lot of scenarios where you've provisioned more servers than you need to meet the traffic you're at, or sometimes just barely enough, or I guess I didn't put it on this graph, but there will be instances where you don't have enough and traffic will exceed what you have the capacity to support. Well, what if we could scale our traffic like this? What if we get auto scale our traffic like this? And so in this graph, this is an ideal. What if we could have the amount of power we need from all of our instances to match our traffic at all times? Well, this is what auto scaling on AWS solves. Now, granted, it will never be this perfect, and the reason for that is, well, you can't make EC2 instances granular enough to, for example, handle just one more user. I mean, that'd be nice, but it's just not possible because you can't get an EC2 instance with like, 1/100th of a CPU core. You can only get one with one full virtual CPU core. And so if 100 active users, is your rule for saying, okay, I need to scale up, well, then you would add another server. But if only 10 or 20 show up after that, well, then obviously the new server is going to have some extra space left over. Anyway, this is an ideal, but what a realistic scenario of auto scaling winds up looking like is this. And so we'll always have a bit of surplus or a bit of a shortage, mainly just a little bit of surplus, but nowhere near as much as we'd have if we were doing this manually and having to guess. Because when you're doing it manually and having to guess, well, if you're on the cloud, whatever, you just take them down and put them back up. But with physical infrastructure, you have to purchase them, set them up, and so on and so forth. Well, as you can guess, auto scaling on AWS solves these two problems. It allows us to automate changes to our scale without our input. Yes, we'll set the boundaries because, well, after all, even though we might be, have the traffic to scale to millions of instances, that doesn't necessarily mean we want to, because that'd be quite a surprise bill. So, of course, you can say, hey, I want you to auto scale within like 3 to 6 instances. But if it goes beyond 6, like if it turns out our traffic needs 7 or 8, well, don't do anything at all. Just send me a notification. Okay, but how do you set up auto scaling? Well, once again, this is actually something that comes largely built in to the various AWS resources. And thankfully, we've actually covered all of the main things we need to know about to get this done. The main player in auto scaling is a CloudWatch alarm. And the process is very simple. So let's pretend that we have an alarm set up to watch the average CPU levels of all of our EC2 instances that are created from an auto-scaling group. Well, our process to set up auto-scaling for this would be pretty simple. Make an alarm that goes off when the metric levels reach a certain level, when they go beyond it. And then number 2 is to tell the auto-scaling group, so that thing that's managing our fleet of servers, telling it what to do when the alarm sounds. And that action is usually, hey, add another instance or take away an instance. So for example, we might have an alarm that goes off if the average CPU level of all of our servers goes beyond 80%. And then we'd have our auto scaling group set up to respond to that alarm by adding 2 instances. Now, that's kind of the simple version of auto scaling, but AWS actually provides a few different ways to conduct your auto scaling that will make things either more manual or more automatic or more fine-grained. The type you choose will be based on your needs. Now, I will mention that they have a very neat type of auto scaling called target tracking that lets you quit thinking about numbers of instances altogether. With that type of scaling, you say something like this. You say, hey, AWS, I want my servers, all of them, to sit around an average CPU level of 60%. And from that point on, AWS will automatically add and remove EC2 instances to try and keep things at that level. It's actually really amazing. Okay. And with that done, our architecture is, well, it's pretty darn invincible at this point. If something fails, ECS and the auto scaling group will make sure that the servers are remade, and we'll also know about it in the logs. If we need scaling, we'll automatically get more instances and containers. And if we need to scale back, maybe traffic lessens up, well, that'll also be handled automatically as well. So as you can see, this is where DevOps in the cloud starts getting a lot of power, because given this, you can imagine just how much of a job you can automate here. Alrighty, so what could possibly be left? Well, we haven't talked about networking and security yet, and if you keep up with all of the crazy security breaches, then you know that this is a key concept to get under your belt.